In this unit, we're going to talk about reasoning, and we're going to talk about two types of reasoning. One is called inductive reasoning, and the other is deductive reasoning. So in today's lesson, we're going to be looking at what's known as inductive reasoning. So what is inductive reasoning? Well, inductive reasoning is reasoning based on patterns that you observe. All right, so that means you have to be given information, and you're basically using a little logic, and you're thinking, okay, what makes sense, right, that links all these objects together. So what is the pattern is basically what you're thinking about for inductive reasoning. And when we're thinking about these patterns, when we're looking at the observed information, we're going to come up with what's called a conjecture. Okay, and a conjecture is basically an unproven statement based on what you've observed or your conclusion based on data, right? So these are conjectures that we're going to make based on our inductive reasoning skills today. So for example, if you take a look at example 1, I want you to be able to describe the pattern and then use your best guess, right? Your educated guess, almost like a hypothesis here, and come up with what do you think the next item will be. So if you look at example 1, I've got 1 dot, 3 dots, 6 dots. What do you think will happen next, and how did you come up with that pattern? So take a moment and use your own words to try to describe the pattern, and then let's think about what happens next. Okay, so I might describe this pattern as you add a row of dots below the previous image, and that row should be one more than the previous item, which makes sense to me, but may not make a lot of sense to you. That's why I wanted you guys to think about your own words. But I'm basically saying if you look at the pattern, we start with 1, then you're going to add 2 below that 1, then you're going to add 3 below that 1. So that means our next term should be, or the next item should have how many dots on the bottom row? Well, it should have 4. So it should be 1, 2, 3, and then 4. So that would be the next item. And you can describe this in different ways. So I've had students say, well, you're adding a diagonal row down the side. Or they're saying you're keeping a triangular shape and it's 1, 3, 6, and then it's going to be 10. So you're adding 1 plus 2 plus 3 plus 4 in that sense. Or you can say you're adding a diagonal row down the side. Right? So lots of different ways you could describe that. Let's take a look at example 2, and we're going to complete this conjecture now. And that's kind of a different type of situation. So if you look at this example, we're saying the number of segments formed by n collinear points is, and you want to fill in the blanks. You want to say, is it always 5 segments? Is it n plus 3 segments? So you want to come up with a rule when you're trying to complete the conjecture. And these can be all different types of problems. I could ask you like, the sum of an even and an odd number is always blank, and then you've got to figure out what will complete that blank. So often what you're going to need to do is create observations. So remember in example 1, I gave you the pictures. In example 2, what I want to do is I want to take the words and create the first few sets of data and then look for a pattern. So let's talk about what this actually means. We want to look at a number of segments formed by n collinear points. What does collinear mean again? Well, hopefully you remember collinear means in the same line, right? So what I'm going to do is I'm actually going to just create a table. So I have points and then segments. And actually, let me do this. Points, picture, image, and then the number of segments. And I'm just going to get a few, maybe 3, 4, 5 or so of these pictures going so I have some information so I can go through and look for a pattern. So for example, if I have 1 point, I know it's 1 dot, and how many segments are there? 0, right? 2 points, 2 dots, how many different segments? 1, right? 3 points, 1, 2, 3. Then I have 1, 2, 3 total segments. Do you see that? Right? 2 of the small ones and 1 big one. And then if we look at 4, how many segments do we have here? 1, 2, 3, 4, 5, 6. So make sure you're seeing how many segments there are. All right, go ahead and look at 5. And you guys tell me, how many segments do you see with 5 points? Okay, well, hopefully you counted out 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, of course, this will keep going. So, dot, 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 right? I'm going to stop here because this already gives me a lot of good information. So now what I want to do is I want to look for a pattern. And often it'll be easy to look for pattern with the segment number. So I'm going to focus on these numbers and let's see if we can come up with a pattern. So what do you notice about going from 0 to 1 to 3 to 6 to 10? Okay. Well, to go from 0 to 1, I added 1. 1 to 3, I added 2. 3 to 6, I added 4. 6 to 10, I added 5. I'm sorry, I can't add. That's 4. My bad. So I added 3, and then I added 4. So I'm doing plus 1, plus 2, plus 3, plus 4. All right. And then if I look at this, hey, you'll also notice that this 2 is 0 plus 1, or I'm sorry, this 1 right here is also 0 plus 1, and this 3 was 1 plus 2, and then this 6 is also 1 plus 2 plus 3, and then to get to 10, you might have also seen it's also 1 plus 2 plus 3 plus 4. So there are different ways to recognize how we went up in the term, right? But what's interesting here is we wanted to be able to describe n collinear points. So how do I figure out what the nth term will be? So if I said, I want you to sit down and you tell me, you know, the 27th term. I want you to be able to tell me a rule for that. How do you find that value? Well, you could say you just take the previous number and add, you know, the n minus 1 value to it, because for the second term, we added 1, so that's 2 minus 1. For the third term, we added 2, so that's 3 minus 1, right? For the sixth term, or fourth term, to get 6, we added 4 minus 1. So you can say you're going to take the previous number and add the n minus 1 term. You can also say, notice it's 0 plus 1, 1 plus 2, 1 plus 2 plus 3. It's a sum of all the whole numbers less than n. So I hope this is making sense, but you could describe this in two ways. So again, what I could say for the first way is it's going to be your n minus 1 term, right? Plus n minus 1. So the term before it, so this means the term before, or, the value before, plus the number of the term minus 1. So again, if I'm looking at how do I get 10, it was 6 plus 4, because the 10th was the fifth term, minus 1 is 4. And that might be a little confusing, so then it might be easier to look at this right here on the side where the arrows are, right? So that was basically just saying the sum of the whole numbers less than n. Right? So again, if we're looking at the fifth term, that's your nth term. To get 10, I added everything before 5. So I did 1 plus 2 plus 3 plus 4 to get 10. All right? So that's what that means. So sometimes it might take a little bit of, working out and writing out your terms. And sometimes it could actually just be pretty logical. So go ahead and try that. You try um, A, B based on examples 1 and 2. So you try A is all about using your reasoning, and B, try that completing the conjecture part. All right, and then let's check your work. Okay, so check your work. Hopefully A was pretty straightforward every other month starting with January, so the next item is July. And then part B, I want you to actually look at my scratch work. This might have been pretty straightforward when you're thinking, okay, positive plus positive is positive. And that's true, and that's the only relationship that I found based on some observations. And when you're playing around with numbers, you want to remember to try all sorts of numbers. Whole numbers, right? Odds, evens, fractions, decimals, especially fractions between 0 and 1, so we often forget to check that. So you want to try out every possibility that that satisfy the constraints of the problem. So we want positive numbers only, so we can have positive odds, evens, fractions, decimals. So try them out, see if you find a pattern, and here the pattern was just all those sums ended up being positive. Okay? Cool. We're going to finish this off in class because I don't want to take up any more of your time. Please make sure you ask if you have questions.